Hey there, space enthusiast. So you've gone and gotten yourself trapped in a black hole, huh? Classic rookie mistake. Don't worry, I've got you covered with this comprehensive guide on how to escape a black hole. Spoiler alert, you can't. But hey, let's explore why that is and what your very limited options might be. I know what you're thinking. I'm never going near a black hole, so why should I care? Well, besides the fact that these cosmic vacuum cleaners are just plain fascinating, understanding black holes helps us grasp fundamental physics concepts that shape our universe. Plus, they make for killer conversation starters at parties. Hey, did you know that time essentially stops at the edge of a black hole? Boom. Instant popularity. Black holes represent the most extreme environment in our universe where the laws of physics are pushed to their limits. Scientists study them to better understand gravity, space-time, and quantum mechanics. And let's be honest, they're just cool as heck. Sorry to burst your bubble, but once you cross the event horizon, the point of no return, you're toast. Not because I said so, but because physics said so. The event horizon marks the boundary where escape velocity exceeds the speed of light. 1. Since nothing can travel faster than light, according to Einstein, who was pretty smart, nothing can escape once it crosses this threshold. Inside the event horizon, space-time gets so warped that all paths lead to the center, no matter which direction you try to go. It's like trying to swim up a waterfall that's flowing faster than you can possibly swim. Actually, it's way worse than that, but you get the idea. You might be thinking, but what if I just use a super powerful rocket? Nope. Here's why typical escape plans fail. Thrusting won't work. Inside the event horizon, all paths lead to the center. It's not that your rocket isn't strong enough, it's that the direction away from the black hole literally doesn't exist anymore. The escape velocity problem. Outside a black hole, escape velocity is just the speed needed to break free from gravity. But inside the event horizon, this concept breaks down completely. The issue isn't about speed, it's about the absence of any possible outward path. I once tried explaining this to my cat by showing how water always flows down the drain no matter how it swirls. My cat just looked at me like I was crazy and knocked my coffee off the table. Maybe she was onto something. While you and your spaceship can't escape once past the event horizon, there are some fascinating phenomena that allow certain things to escape from the vicinity of black holes. Relativistic jets, nature's cosmic fire hoses. Black holes are actually messy eaters. As they gobble up matter, they sometimes create enormous jets of particles that shoot out from regions just outside the event horizon. These jets blast outward at nearly the speed of light, extend for thousands of light years, contain electrons, positrons, and other subatomic particles. How do these jets form? The black hole's intense magnetic fields get twisted around its rotation axis, creating a kind of cosmic particle accelerator. It's like when I tried using a new blender without putting the lid on properly. Stuff went everywhere, but on a much less impressive scale. Hawking radiation, quantum weirdness to the rescue. Stephen Hawking proposed that black holes aren't entirely black. Due to quantum effects near the event horizon, pairs of particles can pop into existence. One falls in, while the other escapes as radiation. This means black holes actually leak tiny amounts of energy and slowly evaporate over time. However, for a black hole the mass of our Sun, this process would take about 10 to the power of 67 years, so don't hold your breath waiting for one to disappear. Since I'm legally required to include some practical advice, my lawyer insisted. Here are some tips for dealing with black holes. Tip number 1. Stay the heck away from the event horizon. This one seems obvious, but you'd be surprised how many people get this wrong. For a black hole with the mass of our Sun, you'd need to stay at least 3 kilometers away from its center. For supermassive black holes like the one at the center of our galaxy, Sagittarius A star, give it a few million kilometers of personal space. Tip number 2. Use slingshot maneuvers if you're in the neighborhood. If you absolutely must visit a black hole, you could theoretically use its gravity for a slingshot maneuver to gain speed for your spacecraft. NASA and other space agencies use this technique with planets all the time. Just don't cut it too close, or you'll be writing a very different kind of travel blog. Tip number 3. Consider harvesting energy from black hole jets. If you're an advanced civilization looking for an energy source, black hole jets could theoretically be tapped for enormous amounts of energy. You'd need to position your collectors near the polar regions of the black hole where the jets emerge. I tried this once with a miniature black hole in my garage, but all I got was a stern warning from the Homeowners Association. While current physics says escape from within a black hole is impossible, science is always evolving. Here are some wildly speculative ideas that might not be completely impossible. Wormholes. Some theoretical models suggest black holes might connect to white holes through wormholes. A white hole is the theoretical opposite of a black hole. Nothing can enter it, but things can exit. However, there's currently zero evidence that white holes exist, and wormholes would likely collapse before anything could travel through them. Advanced physics. We haven't discovered yet. Maybe there's some aspect of quantum gravity or string theory we haven't figured out that could provide an escape mechanism. I'm not holding my breath, but hey, 200 years ago we thought heavier than air flight was impossible, so who knows? What scientists are actually working on? While actual escape methods remain firmly in the realm of science fiction, scientists are making exciting discoveries about black holes. They're mapping the environment around black holes using the Event Horizon Telescope. They're studying gravitational waves from black hole mergers. They're working on resolving paradoxes like the black hole information paradox. I recently read about scientists detecting light from behind a black hole for the first time, confirming another prediction of Einstein's theory of general relativity. The black hole was actually bending space so much that light from behind it curved around and became visible from our perspective. Mind blown. If you find yourself past the event horizon of a black hole, my sincere advice is to make peace with your situation. You're about to experience something no human ever has before, or lived to tell about. As you approach the singularity, you'll be stretched into a process physicists delightfully call spaghettification. Not pleasant, but certainly unique. Black holes remind us that there are absolute limits in our universe, points beyond which certain rules cannot be broken. There's something humbling and profound about that. In a world where we're used to finding workarounds and hacks for everything, black holes stand as cosmic bouncers firmly saying, "Nope, not this time." So while I can't actually help you escape a black hole, I hope this article has given you a deeper appreciation for these cosmic phenomena and the amazing physics behind them. And hey, if you're reading this, you're definitely not inside a black hole yet, so that's something to be thankful for. Remember, when it comes to black holes, the best escape strategy is to never get caught in the first place. Safe travels, space explorers.